Hi, Honors Chemistry students. Today I'm, of course, making all these videos on May the 4th. So, hello, sweeties. May the force be with you. So, today I'm going to start working on Chapter 18 because I believe Chapter 17, the videos I've put up are so good, I don't think I should try to even outdo this guy. I mean, I can't believe he cut all the little circles, and when you see those videos you'll know what I mean. You should have already seen them before you're watching these. Anyway, this is our foray into organic chemistry. If you go into any health profession, or if you want to be an engineer, you are going to have to take organic chemistry, and it is considered one of the hardest chemistries you can go into. Now, I actually enjoyed it. So I think you'll really like it. We don't cover it much in AP chemistry, so that's one of the reasons I really wanted to touch on it. We also don't cover chapter 20 in AP chemistry, so if you read through that, that's probably a good information. I will briefly go over them because I know you won't have had it this year. All right, let's move on. This is going to be a short section because 18A is just an introduction. First of all, organic chemistry. Why is it called organic? Organic chemistry was named that way because it is the study of, they thought it was all the compounds that were made from living things, because coal and oil, they're all compressed living things. We are loaded with carbon. The first Star Trek movie, which was awful, called us carbon units. So carbon is, all living things are made of carbon. So that's why they thought it was organic. Different organic than organic gardening. All organic gardening means is you don't use chemicals and things on your plants. So it has nothing, I used to joke when I'd see organic chicken, I'm thinking, is there another kind of chicken? But so organic was originally defined as any compound that comes from a living thing. However, when they stumbled upon urea, compounds that had carbon in them that didn't necessarily come from a living thing, they redefined organic chemistry as all compounds, the study of all compounds made with carbon. Now, what makes carbon so special? Well, carbon, as you remember, has 4 valence electrons, and it can bond with 4 different things. It can also bond with itself very easily. So it forms thousands of different compounds, and it can form in different ways. It can make single bonds and double bonds and triple bonds. It can form in long chains. It can form in rings. It can form in branches. So you get all different kinds of things. There are many different kinds of alcohols and sugars, and it all depends on the branching. You can also have the exact same formula for a couple of organic compounds and have 2 different compounds just by the way it's shaped. So carbon is special, and this is all in your book, so you might want to say it because it has 4 valence electrons and can make all different kinds of bonds. It also forms strong chemical bonds with itself, and it also forms non-polar bonds with hydrogen. So hydrocarbons are a big segment of organic chemistry, and hydrocarbons are anything that has hydrogen and carbon in it, like gasoline, all your oils, all your sugars, they're all hydrocarbons. Now, structurally, like I said, they can form long chains. So aliphatic organic compounds are compounds that doesn't matter how they're put together, as long as they're in a chain. Those are aliphatics, okay? And we'll talk about aliphatics. Those are alkanes, alkenes, and alkynes. The next kind is aromatic. Aromatics form rings, and they don't necessarily all have to be 1, 2, 3, 4, 5, 6 rings, but that's a very famous ring. It's a benzene ring, and it's a hexagon. But anything that forms rings is an aromatic hydrocarbon. And why is it called aromatic? Because a lot of the compounds that are formed with cyclical arrangement have specific odors. And you'll see, you know, we usually do a lab at the end of the year where we turn this very smelly kind of alcohol and oil, and we turn it into apple scent and wintergreen, because the scents that are in all your plants are actually from aromatic hydrocarbons. Okay, that is all I have to tell you about 18A. I'm going to continue on another video for 18B.